Hello, Calc family. I'm Derek Fritz.
And I'm Andrew Brinkman.
And we're here today to teach you an
extreme lesson on Extrema! Today we'll be learning the definition of the extreme points and critical points.
And then we'll be going over how to determine those points.
And we'll end with the Extreme Value Theorem! Woo! Basically, an extreme value is an absolute maximum or relative maximum of a graph, or an absolute minimum or relative minimum of a graph on a given interval.
Here we have an absolute maximum, which possesses the largest y value in the given interval. Here we have another maximum that occurs where the graph switches from a positive slope to a negative slope, but does not possess as large of a y value as the absolute max, making it a relative max. This also applies to minimums.
A critical point is a point on the graph that the derivative at a certain point, a certain x value rather, is 0 or undefined. So f prime of c equals 0, or f prime of c is undefined. The point c, f of c, would equal the critical point.
Now let's have an extreme recap. So far we learned that extrema are maximum or minimum values on a given interval. These can be either absolute or relative.
We also learned that a critical point is when the derivative is equal to 0, or if it is undefined. We will be using these in our next section.
Now we will be learning the extreme value theorem, also known as EVT. EVT can be used to find the absolute and relative max and mins of a continuous function by comparing the y values at the critical point and the endpoints.
We do this by finding the critical point and by setting the derivative equal to 0. And then we find the x values, there could be multiple of them, and we plug those x values into the function, the original function, and find out the y value of each of the critical points, and also find the y value of the endpoints. Then we compare each of these coordinates and determine the maximum, the absolute maximum, or the absolute minimum of a function. Now let's do an extreme example to further your extreme knowledge on the extreme value theorem. So when you're given a function f of x, you will then, on a given interval, you take the derivative. So for example, f of x equals 3x squared minus 24x minus 1 on the interval negative 1 to 5. We begin by taking the first derivative by using the extreme power rule. So after you derivatize, you get f prime of x equals 6x minus 24. Now, as we learned with critical points a few moments earlier, you set it equal to 0, bring the 24 on the other side, then divide both sides by 6. After doing all that, you get x equals 4. So this value is the critical point that we learned about moments ago. So now we're going to compare the y value at the critical point and the y value at the endpoints. So when you plug in negative 4 into, positive 4 into the equation, you get negative 49, which is the critical point that we found out. And then we also do that to the endpoints, negative 1 and 5. So now we compare the values. If we wanted to find the absolute maximum value, that would be f of negative 1 is the absolute maximum. If we want to find the absolute minimum value, that would be f of 4. Now let's do another extreme example. The extreme value theorem also works with trigonometric functions. For example, if you have f of x equals sine squared of x plus cosine of x, you can still use EVT to determine the absolute minimum and absolute maximum of a function. So first of all, we begin by taking the first derivative. After doing so, we get f prime of x equals 2 times sine of x cosine of x minus sine x. So then we set that equal to 0, and then solve to find the critical points, which after using calculus and math, we determine are pi of 3, pi, and 5 pi of 3. So on a given interval, 0 to 2 pi, each one of the critical points is within the range. So we're going to compare the y value of the endpoints and the y value of each of the critical points. So we have an f of 0, and f of pi over 3, and f of pi, and f of 5 pi over 3, and an f of 2 pi. So those are some extreme values that we're about to find. So after plugging in the equation and using your reference triangle, or however you solve it, you can determine that f of 0 is equal to 1. F of pi over 3 is equal to 5 over 4. F of pi is equal to negative 1. F of 5 pi over 3 is equal to 5/4. And finally, f of 2 pi equals 1. So after comparing all the values, we determined that f of pi over 3 is the absolute maximum value on this given interval, and f of pi is the absolute minimum.
Pretty extreme, huh? So in conclusion, today we learned the definition of extrema and critical points, how to find them, and how they're applied.
We apply them in the extreme value theorem by comparing the critical points and the endpoints and determining the absolute maximum and minimum values of a continuous function on a given interval. There you go. Okay. Special shout out to our camera lady, Abigail Meza, who did an extreme job of cartwheeling and filming us.
And we also have an extreme shout out to our calc teacher, Mr. Parr, for all the help he's given us over the year, and our parents and family, and all of you students out there for giving us your continued support.
Yes. Hope you guys all enjoyed our extreme lesson and have an extremely awesome day.
Hello, Calculus family. I'm Derek Fritz. Extreme lesson on
a critical point. A critical point. A critical point is sorry. A critical point is when
now let's have an extreme. Sorry, our absolute CVT, also known as extreme value theorem.
Okay, wait, yeah. Okay, wait.
No, that's